Welcome back children, I'm Srinivasan here. We are discussing exercise 1.3 ninth problem. Already this problem I have done in a different way. Now I am going to do in another way. Whichever you feel this is easier, you can follow it. The first step, the first part 1 to 1 is going to be same, but on to part there will be a small difference. Let us do first one on to, 1 to 1 we will do. Let us take two elements in the domain belongs to R plus. We know R plus is a real number of positive. We forgot about the negative numbers. Now we imagine that their images are equal, so that we will prove that their elements are equal. So f of x is given as 9x squared plus 6x minus 5. Now as we are going to take x1, you change x to x1. So you have 9x1 squared plus 6x1 minus 5 equals 9x2 squared plus 6x2 minus 5. So negative 5, negative 5, you can remove that. Now bring everything on one side. 9x1 squared minus 9x2 squared plus 6x1 minus 6x2 equals 0. Okay children, now in this you can take 9. If you take 9 outside, you will have x1 square x2 square plus 6. If you take out, you have x1 minus x2 equals 0. Now in this we have a plus b, a minus b, x1 plus x2, x1 minus x2 is there. So we can take this x1 minus x2 outside. So you will have x1 plus x2, a square minus b square formula, a plus b, a minus b, plus 6 alone will be there. And this cannot be equal to 0. So x1 minus x2 equals 0, because these are all positive. They will be greater than 0 because 9 is there, 6 is there. So x1 minus x2 can be equal to 0. So x1 equal to x2. Therefore f is 1 to 1. Okay children, 1 to 1, this is the proof. We started with the images and we have showed the elements are equal, and I showed that this is, I told you this is not equal to 0 because 6 is there. Okay children, this is for 1 to 1. You please copy down. Next we will go for onto function. I'll erase this one. We know how to do onto function. I did it in a complete square method in that another the same question in another form. Now I'm going to do it in a normal method. I'll tell you how to do this. Now to verify onto, let us take this as y equals 9x squared plus 6x minus 5. Okay children, now I'm going to add 1 and subtract 1. Okay, now what happens, 9x squared can be written as 3x squared. Now I am writing 6x as 2x, 2 times 3x into 1 plus 1. Now I combine this minus 1 and minus 5 as. Now you see a squared plus b squared, 1 can be written taken as 1 squared, 2ab. So a squared, b squared, 2ab. So it can be written as a plus b the whole squared minus 6. Hereafter your y is 3x plus 1 the whole square. We take this one. This is equation number 1. Okay children, hereafter forget this quadratic, you take this quadratic equation and shortcut form. Okay children, this is what I did in a complete square method. I brought it to this particular part. You can take this. Now we are going to solve this for x to find the inverse. Minus 6 on this side, it will be y plus 6 equals 3x plus 1 the whole square. To remove the square, take the positive square root, equals 3x plus 1. Now move that 1 on this side, y plus 6 minus 1, and bring the 3 here. This is what the inverse is. We got the answer. So to prove this as onto, we have to substitute this x value in f of x. Hereafter your f of x is this. Correct children? So in this, if you substitute it, because these and these are same. Okay, we have reduced it. So you can substitute in this. Now substituting in equation 1, what you will get? Okay children, I am going to substitute this value in equation number 1. Now tell me, f of x equals, x means this whole term here. So 3x, so 3 into x is root y plus 6 minus 1 by 3 the 3x plus 1. So 3x plus 1. Can you see this? 3 into x plus 1 the whole square. We need to square this plus 6. Only this step alone it's little difficult when substitution. Other things are going to be very easy. You subtract this. This gets cancelled. 3 and 3 gets cancelled. Minus 1 and plus 1 gets cancelled. Now square and square root will get cancelled. You will get y plus 6 Then take this 6. This must be minus 6. It was minus 6 there. So minus 6 plus 6 minus 6 gets cancelled. You get f of x equals y. So when you get f of x equals y, we know this function is f is onto function. F is onto function. Why? Because we know the rule for every y belongs to the capital Y, that is your codomain. There exists an x belongs to the capital X, which is domain, such that f of x should be y. This is a definition I have given in all the questions. F of x equal to y, f is onto function. So we have proved one to one and onto. Therefore, f is invertible. This is your final answer. F is invertible, and your f inverse is here. Your f inverse of y is root of y plus 6 minus 1 by 3. So this completes the solution of this question, children. This is another way of doing it.